Hello everybody, we are going to look at three formulas today just to go over some basics of transposing. No particular order, just we're going to look at a squared plus b squared equals c squared, which is commonly used for our Pythagorean theorem. X plus y equals z, we're going to turn that one around. And then v equals d over t, which is our velocity formula. Velocity equals the distance over the time. So let's just start off with one that's fairly straightforward. I have a value of x that's being added with y, it equals z. So if I wanted to solve for something like y, with any transposing, there's a ton of different ways to do this. And all of them are fantastic. It's about being comfortable with what the process that you would like to do. And really the fundamental of transposing is we always have to have a balanced equation. And I like to think about, you're always trying to perform the opposite function. So x plus y equals z. If I'm trying to solve for, let's solve for x. Y is being added to x, so the opposite of addition is subtraction. I'm always trying to perform that opposite function. That's going to create my balance scenario. So x plus y. If I subtract y from this side, what I do to one side, I will have to do to the other. So I will subtract y. And then I will be left with x is equal to z minus y, or z subtract y. If I wanted to solve for, we go back up to the top, I'll rewrite this, x plus y equals z. If I wanted to transpose for, we just solved for x, let's solve for y this time. It's no different. X is being added to y is being added to x. So if I subtract x from this side, what I do to one side, I'll have to do to the other. So then I'm going to subtract x from here. And I end up with y is equal to z minus x. So we follow that same principle with that. Okay, and now we've got a multiple, a couple of things that we have to be considered of. If I want to solve for, say, just a value of b, I have to worry about the fact that a squared is being added to b, but also this squared function. And we just follow along that same principle of take care of what the opposite function is. Sometimes it works to move the addition first. Sometimes it works to move the squared function first. That becomes, let's be comfortable with the understanding of it. Sometimes it works in one scenario, not always. For this formula, the way this works, I know that the simplest function, let's solve for a, just all on its own. So I can move, we could try to move that squared function first. It becomes a little bit more complicated. So if I want to solve for a, the easiest thing for us to do, if we're doing add to b squared, let's subtract b squared. Those two will cancel out. What I do to one side, I have to do to the other. So I will minus b squared from this. And I am left with a squared is equal to c squared minus b squared. So I'm not done yet because I'm trying to solve for a all on its own. And if I do this, I must get rid of that square root. Sorry, that square, and the opposite of a square is a square root. So if I square root this side, what I must do is square root the entire function over here. So if I square root this entire function, that's very important. Now these will cancel out and I'm left with a is equal to the square root of c squared minus b squared. What you have to be careful with this, and it depends on the calculator that you have actually if you're running through this. A lot of the times what the mistake that is made is that we will put in our calculator the square root of this value squared minus b squared. And what your calculator thinks is that you only want to square root the c squared. And we come up with incorrect. So my advice for you, as soon as this goes into a calculator, that square root function is established, then I use brackets. So I'll put a bracket, c squared minus b squared, then close the bracket. That way your calculator knows that, hey, I want to do that entire function. So the last one that we have to do is we're going to transpose v is equal to d over t. And let's solve for d. When it's a formula like this, maybe the easiest thing for me to move is just the value on the bottom. If I want to solve for t, that might be a couple of steps. And there is a shortcut, and it's good to learn the shortcuts, but it's also good to learn the fundamental of it, so we can do it every single time, no matter what the formula is. So let's solve for d. Well, it is d divided by t. So the opposite of division is multiplication. So I do times it by t on this side. So I will multiply it, by t on this side, and I'm left with t is times, my mistake, get going too fast, t times v will equal d, or the distance in case of that formula. So let's do one where we actually go and solve for t. V is equal to d over t. There is a shortcut to this. Let's not jump to the shortcut right away. Let's see how this is actually done. So if I want to solve for the value on the bottom, it's a two-step problem. And what I always like to do with any formula, if you can get it linear like this, it's really easier to move everything from that point. So if I'm going to solve for t, it's a two-step process. So I'm going to multiply by t, multiply by t. And you're like, Jason, it's the exact same formula. I agree. T times v is equal to d. Now if I want to solve for t, t times v, the opposite is division. Divide by v, and I'm left with t is equal to d over v. Oh, you might not be able to see that very well. So I'm going to write this dropped off the side there. So I'm left with, once these cancel out, the formula that I would be left with is t is equal to d over v. And if you notice, from the very beginning, all we've actually done is trade in place. And that's the shortcut with a formula that's built like this, is that I can just interchange the value by itself with the one on the bottom. I can't just move that value up here. I can't move distance and change it with velocity in that formula. I can't do it. But if any value that is isolated by itself, I can interchange with the value on the bottom. I hope this has helped. And if you have any comments, if you'd like to see another formula and how it's transposed, let me know, and I'll see if I can get it out for you. Thanks. See you in the next one.